Welcome one and all. We are going to see the paper regarding scheduling grid task in the face of uncertain communication demands. So what is scheduling grid task? Scheduling grid task is nothing but we are going to schedule the task present in the grid environment. What is uncertain communication demands? Uncertain communication demands means lack of definite value. That is, we can't predict the input values. So what uncertainty we are going to consider is it is regarding the fluctuation of resources. So what is fluctuation of resources? It is nothing but while giving the task to some of the processes, it will just take that process and it will just schedule, or it will just proceed with its execution. Without appropriate assessment of these tasks, it will lead to some erroneous situations. So in order to tackle all these scenarios, we are going to frame a framework, that is IPDT fuzzy scheduler, which is going to handle this uncertain communication demands. So this is the flow for our system, that is IPDT fuzzy scheduler. So what we are going to do is we are going to take the acyclic graph and we are going to extract the node information present, and then we are going to create the nodes. That is, first of all, we are in need to create the grid environment. No, so for that particular purpose, we are all for formulating these things. Then we have to estimate the communication demands. Communication demands is nothing but the process. So which particular process is being given to which particular node, and then we have to determine some certain attributes such as host capacity and several cost constraints. Cost constraint is nothing but the traversing cost and then the execution cost and all. Then we are in need to schedule the IPDT. That is, we are in need to solve the IPDT. What is IPDT? Integer programming for discrete time. So this is IPDT. After that, we'll be getting a list that produces which particular task is being executed in which particular host, and the starting time for the task and data transfer time. So this is the system architecture diagram. Next, we have to open the NetBeans and then we have to select the grid task. This is our project. Then we have to start the WAMP server. So you have to run this tree.java. Totally we are having 5 graphs, so you can just select any of the graph and you have to just construct that particular graph. After this, we are going to initialize each and every node. That is, we are going to form a grid environment. So this is a grid environment. After forming the grid environment, we have to give IDs. That is, we are going to give names for those nodes. After this, so this is the node's particular ID. We are going to realize each and every node by its ID. And after this, we are in need to evaluate the task dependencies. So what is task dependencies? The output of one task is given for the input of another task. That is, we have to take the output of one task and we have to give it to the output of for the input of another task. After this, you are in need to run this tree.java. So we are in need to estimate some host capacities, and then the task dependencies link capacity, and then the data transfer rate, and then the time for data transfer. And this is the nodes processing time. After this, we are in need to formulate the IPDT. First of all, we are in need to create the FI. So what is this FI? If at all one process is being allocated to one node, its status is given as 1. So this is the task dependencies. Each and every node is being provided with the ID and its respective task. So we are going to estimate the status. So this is the processing time after giving the task or after allocating the task to the particular node. After this, we are in need to estimate the sigma value, that is QoI value. So for each and every node, it is being allocated with a task and its respected QoI is being estimated. So we are having two values, say true value and expected value. So using those two values, the last QoI is being executed. Now we are going to solve the IPDT. So this is the first step for the IPDT. We are in need to estimate the maximum time, that is when allocating all process to the grid. So which processor takes the highest time? So we are going to estimate that particular time and we are going to estimate the minimum time. After this, we are in need to estimate the task executed on a single host. So this is the first IPDT constraint. After this, we are in need to estimate the constraint 4, that is time taken for transmitting a single bit along a link. That is, for transferring a task between T0 to T1, it requires 2 seconds, and after that is its total transferring capacity is of 2 seconds. And how much bytes are being transmitted? Means 703 bytes are being transmitted between T0 to T1. And then next is time taken for health host to execute a single instructions. So this is a time taken for a single host to execute a single instructions. So we have estimated all these things by when one particular instruction takes this particular time is, then what is the total instructions, what are the total time that is being taken for executing overall instruction. And after this we are in need to solve the LHS and RHS part. Of course LHS will be greater than the RHS as per the IPDT. And then we are in need to calculate the constraint. That is, this is the constraint file. Totally minimum number of instructions for which each and every node can process. And after this, the upper limit, that is T-val. T-val is nothing but the computation uncertainty for a particular task which is being allocated to a particular node. And after this, we have to execute the constraint file. So this constraint file is for determining only one task should be allocated to one node. So all other tasks, if at all any other task is being wrongly allocated, means it will be transferred to 0. So that is the thing. And finally we'll be getting the output as this thing. That is, we are going to estimate the statistics report. So the data is being executed at node 0, it starts at time 2, and data is being sent within the link T0 T1, it starts at time 36, and D0 and data is being sent in this link, it takes the time 37. Similarly up to T6 the data is being first of all sent, and each and every node starts its execution after the completion of the transfer. So this is the execution statistics.
Thus, we have evaluated the execution statistics, I mean when the data transfer should take place between the nodes and when the process execution should be carried out consequently. Thus, we have arrived at the conclusion. Thanks for listening.